Healthcare workers who perform heavy lifting, whether they be nurses moving patients from bed to bed or radiologists moving heavy equipment, are at risk of musculoskeletal disorders due to improper heavy lifting form. According to OSHA, the incidence rate of musculoskeletal disorders in nurses, orderlies, and attendants is 249 per 10,000 workers. More specifically, lower body position, or the knee angle, is crucial in determining proper versus improper heavy lifting form. From this problem arises the need not only to detect, but to also correct improper heavy lifting form. We hope to address this need by alerting healthcare workers when they are using incorrect form so that they may make a conscious effort to correct it in order to reduce these occurrences and lower their risk of developing musculoskeletal disorders. Our device consists of 3 major hardware components: an EMG to measure upper body exertion indicative of whether heavy lifting is being performed or not, a flex sensor to determine knee angle indicative of proper or improper lifting form, and the MyRio device in conjunction with LabVIEW programming.
First, the user runs the program. The first thing that happens is that a pop-up window appears to show the user how to configure the hardware on their body. The window provides step-by-step instruction on how to place the sensors on the body. Step 1 shows how the device is attached to the belt. Step 2 explains how the knee brace is oriented. Step 3 demonstrates the placement of the EMG electrodes. Step 4 shows users how to calibrate the device using a knee push-up. This activity was chosen for calibration because it allows the user to activate their bicep muscles with a significant portion of their body weight, which is a representation of accurate heavy lifting activity relative to the specific user. The last set of instructions on this pop-up window direct the user to close the window and move on to the calibration step.
However, if it's the user's first time using the system, they may choose to create a new user profile before calibrating.
In the calibration step, the user is asked to perform a push-up as shown in the instructions, and the user will have 5 seconds to do so. Once the calibration is complete, the user is now ready to press record. Once this button is hit, the good and bad form count will update live on the top right pane. When the user lifts a heavy object with knees straight, the system recognizes that bad form is being used. When the user lifts a heavy object with knees bent, the system recognizes proper lifting form.
When the workday is over, the user deselects the record button and can choose to save their data under the user profile. Finally, the user can end the session by selecting the End button. Alternatively, the user can choose to discard their data, automatically ending the program. The main program, which the user actually experiences, is the computer main VI, and its purpose is to provide the user with a series of controls on the front panel which allow the user to therefore change the states of the computer main VI and the main VI, which is deployed to the MyRio. The front panel of the computer main VI shows the current states of both VIs and therefore demonstrates how they stay synchronized with a slight delay. For example, both VIs are currently in the wait for user state. When the user presses calibrate, the computer main VI first changes states followed by the main VI.
This is made possible by creating different clusters of controls and indicators and then making shared variables out of these clusters so that they can be passed back and forth between VIs. As a result of this, even though the main VI, which is run on the MyRio, contains the majority of the programming details for the project, the user never has to manually run the VI or interface with it at all. Instead, all the data acquisition is controlled from the computer main VI. This is a very important feature because it allows the project to run on Wi-Fi without bandwidth limitations. Without this feature, all of the raw data analysis and logic computations would have to be done on the computer itself, which would therefore mean that the MyRio would have to constantly transmit both EMG and flex sensor raw data to the computer over Wi-Fi. However, because of the shared variables, all of the computations can now be performed on code, which is directly deployed to the MyRio, and the only data that needs to be transmitted back to computer are the updating counts for good and bad form.